In this video, we're going to have a look at similar shapes. In particular, we're going to have a look at similar triangles. At the top right here, you can see our definition of what similar shapes are. This was taken from the previous video. Shapes are similar if the corresponding angles are the same and the corresponding sides are in proportion. Okay, so let's try and use that within our first worked example. You may need to pause the video to copy this down. So we want to calculate the length of the side marked X. The diagram is not drawn to scale. Importantly here, the question doesn't say that these are mathematically similar. Okay, so we aren't told for a fact that the corresponding angles are the same. They are actually, but we need to maybe think about why they are to start off with. So see if we consider this angle in here, whatever that angle is there that I've highlighted in red, the angle vertically across from it will be the exact same. So I can go ahead and label this guy here, whatever the red is going to be the exact same as the other red. Okay. You'll notice as well that two of the lines have an arrow on them. That is used to signify in mathematics that two lines are parallel. So this line here is parallel to this line here. And there's a lot of different angle properties we can use with parallel lines. Okay. We have the property of alternate angles, or you might know them as Z-shaped angles. I'm going to trace out a Z shape here. If you can see that Z shape, we can apply the fact of alternate angles are equal. So this angle in here in green is the same as the angle down here. And then once I know that, I can then say that the other two angles are the same as well. Okay, so we've kind of proven that the angles are the same. Okay, so what I like to do now is, in order to work out X, I actually like to draw these triangles separately, and I like to orienteer them the same way. What I mean by that is I like to have them both facing the same direction. So what I'm going to do is I'm going to draw these two triangles, and I'll draw this one here, and I'm going to try and match up the colours. So I want to have red here, green here, and blue here. Okay, so if we have a look at the triangle here, we can see that from here to here is 20 centimeters. So that means that from there to there is 20 centimeters. From here to here is X. So I'll say that that bit is X. Then if we have a look, from the red to the blue is 8 centimeters. And from the green to the blue is 10 centimeters. Okay, we've now got all the information that we need, and we can now start to use this to work out the value of X. So these triangles are similar, so we can go ahead and apply our scale factor. To work out the scale factor, we do the new over the old. The new shape is the shape that we are working towards. The new shape is the shape that has the unknown. Okay, so this is our new shape here on the left hand side. So I want to find the sides that are corresponding to each other, and we can see that it's this side and this side. I have all the information for that, and because this is the new shape, the one we're working towards, my scale factor is going to be, I'll get my pen, 20 over 8. You can simplify that as a fraction, or you can type it into your calculator, and you should find that you get 2.5. Essentially, to get from here to here, we've multiplied by 2.5. In order to work out X, I'm going to multiply 10 by 2.5. So X is 25 centimeters. Okay. So you identify your scale factor and then you scale up as appropriate. We should have had an expectation going into the question, because this side was bigger than the corresponding side, we would expect this side to be bigger than this corresponding side, and it is. It's 2.5 times bigger. Okay, one more example. Calculate the length of the side marked X. Once again, the diagram's not to scale. Once again, we're not told that the shapes are mathematically similar. And so far, similarities involved two shapes, but we only seem to have one shape here. But hopefully you'll be able to see that in fact we have two triangles, the small triangle and the large triangle. Just like in the previous video, the question would have these arrows here to indicate that they are parallel. Without having the fact that they're parallel, we wouldn't actually be able to say that they're similar. Okay, so what I'm going to do is I'm going to draw both triangles. I'm going to draw the small triangle and I'm going to draw the large triangle. Okay, hopefully you can see that the top angle is shared by both triangles, so it's going to be equal. But let's think about this angle in here. Okay, these triangles are similar if this angle in here is the same as this angle in here. But how can I show that? How can I prove it? Well, once again, we're going to use these parallel lines. If you look, we've got some corresponding angles here and here, or it's like an upside down backwards F. I don't know if you see that. So whatever this kind of orangey colour is going to be the same here. And therefore the green, the other side is going to be the same. Okay, so let's fill in some information. In the small triangle, this length here is 12 centimeters and this length here is X. In the large triangle, this length here is 20 centimeters and this length here is 25 centimeters. 25 because it's the full length, 12 and 13. Okay, so we're now going to use our scale factor. So the scale factor is the new over the old, where the new shape is the one that we're working towards, the one where the unknown is. So hopefully you can see that this is the new shape. So we're going to take the corresponding side, so it's going to be 12 over 25. 12 over 25. Okay, if you can simplify it, simplify it. If not, you could just type this into your calculator, and that comes out to be 0.48. Just clear this, and this. 0.48. That implies that to get from here to here, I've multiplied by 0.48. So here to here, I've multiplied by 0.48. Therefore, from here to here, we need to multiply by 0.48. So X is going to be 20 multiplied by 0.48. We're clearly expecting our answer to be smaller than 20. We should be getting 9.6 centimeters, and that is indeed smaller than 20. Okay, hopefully that was helpful. These questions are a wee bit more tricky. They do come up a wee more frequently at National 5 level. Thank you very much.